It's easy to get wrapped up in a movie and focus in on just that one shot. Pleasing the audience's eyes is hard work. There's more to it than pointing a camera and filming a scene. Each image is carefully composed, even when countless frames flash before our eyes. Believe it or not, geometry is a main part of the cinematographer's toolkit for creating beautiful images. To do it, they use principles we can understand using mathematical concepts of congruence and similarity. Congruent forms are exactly the same shape and size. The ratio of sizes of corresponding parts from one to the other is 1 to 1. Congruent forms are also similar. Similar forms are the same shape. Their corresponding parts have the same size ratio. The ratio determines the scale of one with respect to the other, so a shape's proportions are preserved. This larger triangle's dimensions are twice the smaller ones. The ratio is 2 to 1. Cinematographers often use a method called the rule of thirds. They divide the screen into 9 rectangles and place an image off-center at an intersection. This practice is considered to make the images more interesting than placing a subject directly in the center. These rectangles are all congruent with one another and similar to the entire frame, in the mathematical sense. Similar forms are the same shape, and corresponding sides all have the same ratio. Therefore, two objects of different sizes but the same shape can be considered similar since their proportions are the same. For example, one small rectangle within the larger frame is similar to the largest rectangle. This is because all corresponding angles are the same, and each side of the smaller rectangle is 1/3 the length of the corresponding side of the larger rectangle. And the ratios of the length of the short side to the length of the long side are equal for both. Two small rectangles are congruent because not only are they the same shape, but since the sizes of corresponding sides are identical, they're also exactly the same size. Now that's a great shot. Huh, this looks like the Capitol building, but it only stands around 7 feet tall. It looks like the same shape, but it's definitely not the same size as the real Capitol building. This is Legoland's Mini USA. It has a model version of Washington, D.C.'s monuments, including the United States Capitol building. The real Capitol Statue of Freedom alone stands 19 feet 6 inches tall. Similar forms are the same shape, and corresponding parts have the same ratios. This ratio determines the scale of one object with respect to the other. Proportions within a shape are preserved. Congruent forms are similar, but always with a ratio of 1 to 1. So that's why they're the same shape and size. Now back to our Capitol. Parts of its form are similar, but not congruent to the form of the corresponding parts of the actual building, since it is smaller than the original. Measurements can reveal that it was built using a scale of 1 to 20, meaning the relationship between the model and the original. Even if it's not the real thing, it's still a Capitol experience. Our grand old flag stands for the American ideals, liberty, and justice. So, great care is taken in making new flags. Standard flags usually are geometrically similar to one another. That means flags of the same size are also congruent. Similar forms are the same shape, and their corresponding parts have the same ratios. This ratio determines the scale of one with respect to the other. Proportions within a shape are preserved. Congruent forms are similar, but always with a ratio of 1 to 1. So that's why they are the same shape and size. This smaller flag is similar to the larger one waving in the wind because it has the same internal ratios and angles. Compare the rectangle shapes and even the stars and stripes. Their corresponding sides all have the same ratio, even though one is much larger than the other. The smaller flag has a width of 2 feet and a length of 3 feet, and the larger one has a width of 4 feet and a length of 6 feet. In both, the ratio of width to length is 2 to 3. The flags show the proportion of 2 to 3 equals 4 to 6, the same as 2/3 equals 4/6. When the overall size of the flag is proportionately increased, here it's doubled, the star field's length and width are similarly increased as well. The height of the star field in all flags is the height of 7 stripes, while the height of the entire flag is always 13 stripes. And every measurement on the larger flag here is twice the corresponding measurement on the smaller one. Not only are internal ratios preserved, but the ratio of a measurement on the large flag to the corresponding measurement on a similar small one is always the same, here 2:1. These two medium-sized flags are congruent. They have identical forms. The corresponding measures have a proportion of 1:1. If we put one on top of the other, they match everywhere. That's one Star-Spangled Banner. Life beneath the water's surface is as diverse as the ocean is wide. From serene scenes to creepy crawlers, you can swim past sea life to catch the concept of similarity right before your very eyes. Check out these shark pups. They're predators in the making. And unlike many familiar animals, the shark pups grow proportionally. Their parts all grow by about the same ratio over any period of time. So, the baby and its mama are similar. Their forms are the same shape because their corresponding parts maintain about the same ratios as they grow. The ratio of one measurement to another within a shape is a kind of internal ratio. In similar forms, a proportion can express the equality of a ratio within one shape to the corresponding ratio in the other. Look at the baby shark. Its fin is about 1.5 inches, and its total body length is about 15 inches. That's a ratio of 1:10 for the length of the fin to the length of the body. Now look at the mom shark. Its top fin is about 6 inches, and its total body length is 66 inches. The ratio of fin to body length is about 1:11, nearly the same as the pups. Of course, in biology, there's always individual variation. The relationship can be expressed in the form of a proportion, as 1.5 to 15 is approximately equal to 6 to 66. The baby's ratio of fin to body length is roughly the same as the adult's ratio of fin to body length, about 1:10. We can also see the sizes of the same parts in one animal compared to the other. For fin lengths, the ratio of the babies to the mothers is 1.5 to 6, or about the same as 1:4. For body size, it's 15 to 66, about 1 to 4.4. Notice that the two ratios are nearly the same. They're both around 1:4. This is the scale of the baby to its mother. The pup's about 1/4 its mom size. Now, take a peek at another creature of the deep. This nautilus, a mollusk, grows by adding new sections to its shell, and each new section is similar to the older ones, even though it's larger. This growth forms a spiral pattern, in which each new section follows a proportion established in the rest of the shell. This allows the nautilus mollusk to grow into a spiral shape, keeping its proportions equal between adjacent sections. To think you can see all this in a day at the beach, jump in, the ocean's open.